Hello and welcome. In the last video, we had a discussion about FSMs for all flip-flops. Now in this video, we will see how to draw the sequence detector using Mealy and Moore FSMs. Okay, and we will see overlapping and non-overlapping cases for Mealy and Moore FSMs. Before moving to this, let's have a little bit of theoretical discussion on what is the main difference between Mealy and Moore FSM. Okay, now we will see 2 points. First 2 points we will see, and we will try to put those points into practice. Now, as you can see on the screen, the box is represent the difference between Mealy and Moore FSM. So the first point says that in Mealy FSM, output is a function of present state and present input. Whereas on the other hand, Moore FSM output is a function of present state only. Okay. Now we will see this point by using this block diagram. As you can see on the screen, these are the block diagrams for Moore and Mealy FSM. Okay. Now see, in Mealy FSM, output, this is what the output state. Okay. This is what the present state, which is sequential in nature, and this is what the next state logic, which is combinational in nature. Okay, now see, the output state, this output logic is a function of this present input, okay, and this present state resistors. Okay, so output is a function of present input and present state, whereas in Moore FSM, the output state, this output logic is a function of present state only. Okay, there is no any input. Okay, this is what the first point. Now we will see a second point. What the second point says, generally it has fewer states than Moore machine, whereas in Moore FSM it has more states than of Mealy FSM. We will see this point by using one example. Okay, we will see a example of sequence detector for 101 using Mealy and Moore, and we will understand this point. Moore FSM required more state, whereas Mealy FSM required less states than of Moore FSM. And these are the theoretical points. You can go through these points. Okay, now we will see the state diagram representation for 101 sequence detector. Okay, let me take different pen for this. Now see, this is what the 101 sequence detector. Okay, now overlapping sequence detector is there. Okay, for overlapping sequence detector, we will see, first we need to make a small table for this. As 101 sequence detector is this. Okay, now only 3 states will be needed here for 101. Just draw 3 states. You can take any name. I am taking A, B and C. Okay, 3 state. This is what reset. Okay, 1 0. Okay, if 0 is there, it will remain in A state. Okay, and output will be 0. At this, output will be 0. At this, output will also be 0. Output will be 1 whenever sequence is detected 101. Okay, now make a simple table like this. A is reset. Okay, B is here. What is the input at B state? 1. Okay, then put 1. Take C, what are the inputs? 1 0. Okay, now take 1 0. Very simple. Now if at B state, at A state 0 is here, it will remain in 0 A state. 1 is here, so it is going to B state. Okay, now at B state 0 is here, so it is going to C state. What happen if 1 is there? So for that, take this 1, okay, and next is 0. Okay, take 1 opposite of that. Let me repeat, this 1 and 0 is here, to take 1 opposite of this. Okay, now discard first bit and see 1 is remaining. Compare this 1 with this table. Okay, this 1 is B. Okay, so just it will remain in B when 1 is there, and output will be 0 because sequence is not detected. Similarly, take at C state. Now at C state, this 1, this 0. Okay, this 1 0, and if we take 0 here at C state, if we take 0, okay, now discard this first bit, compare this 0 0 with this table. Nothing is here, right? 0 0. Discard another bit, compare this 0. 0 is here, no. Discard this 0 also, and nothing is there, so it will go to initial state, reset state, when 0 is here, and output is 0 because sequence is not detected. Similarly, take 1 0, this 1 and this 0, and take 1 because previously we have taken 0, right? Now sequence is detected, the output will be 1 definitely. Now discard this first bit, compare this 0 1 with this table. 0 1 is not there. Discard this 0. Now compare, 1 is here. Okay, now 1 is nothing but B. Okay, so from this C it will go to B 1 when there is 1. Okay, so 1 is there and sequence is detected 1 0 1, so output will be 1. Very simple. So this is what the same diagram for Mealy overlapping case. Now if we see Mealy non-overlapping, it is also very simple. Now just here in non-overlapping case, same procedure, make a table. First make the states A, B, C, because 1 0 1, right? 3 bits only, so make A, B, C. Okay, this is what reset. If 0 is here, it will remain in same state 1 0. Okay, now make a table. A is reset state, B is 1. Okay, see this 1, C this 1 and 0. Okay, 1 0. If you make this table, it become quite easy for you to draw any FSM, and this is what the shortcut trick is. Okay, now see at non-overlapping case, at A state 0 is here, so it will remain in A state. 1 is here, so it is going to B state. Okay, at B state, if you are at B state, let me put 0 here. Okay, for this A, and here also 0 because output will be 1 when 1 0 1 sequence is detected. Okay, now see, just take at we are at B state. Okay, 0 is completed. Okay, now what happen if 1 is there? So take this 1 and here is 0. Now take opposite of this. What is opposite of 0? 1. Discard this first bit, Okay, now see, 1 is remaining. Compare this one with this table. So 1 is nothing but B, so it will remain in B only. 1 and output will be 0 because sequence is not detected. Okay, now see, 1, this 1, this 0, and we are at C, right? So this 1, 0, and next bit is 0. What will happen? Discard first bit, 0 0. Compare this with this box or table, no 0 0, right? Discard another bit, compare with this 0, no state with 0, right? Discard this bit. Now nothing is there, so it will go to its reset state, 0, and output is 0 because sequence 101 is not detected. Now see, 101 in non-overlapping, whenever sequence is detected, it will go to its reset state. Let me repeat. In non-overlapping case, whenever 101 sequence is detected, or any sequence which you are taking, for example 1011, if this final sequence is detected, it will go to its reset states. Now here 101 is final sequence, 101 is detected, it will go to its reset state, and 101 sequence is detected, output will be 1 1 1. So this is what, very simple. You can compare this with this diagram, same. Okay, so this is what all about the Mealy FSM overlapping and non-overlapping. And if you follow this trick, you will find it quite easy to draw this FSM. In the next video, we will see how to draw the sequence detector using Mealy FSM, and we will see how one state will be more in that Mealy FSM. Okay, so I hope you understood this concept of sequence detector using Mealy, overlapping and non-overlapping. And also I hope you enjoyed this video. Thanks for watching.